Hi there and welcome to this video for Senior Physics looking at quantum mechanics. In this video we're going to explore the PhET simulation of the photoelectric effect. So if you click onto this website here, and I've put a link on the iTunes U course for you, this will take you to a site on the PhET website, and I'm just going to open it up now. And when you go onto that site, this is the file that will be generated. Now basically what we've got there is we've got a lamp, we've got our photoelectric cell, this is our metal plate here, and this is our anode here. And basically what we can do is we can change the wavelength of the different types of materials. Up here, of the different types of light. Up here we've got our intensity. Now what we've got here is sodium. So what I'm going to do is I've got sodium metal here, and I'm going to click on this file, this button here, which gives me the frequency and the energy in electron volts. Now what I'm going to do is I'm actually going to put my intensity at 50%. 50% means I've got plenty of light which is going to be generated. Now what's going to happen is I'm going to increase the wavelength here. So as I increase the wavelength, what you'll notice is nothing happens. In red, nothing happens. We go into orange, nothing's happening. Go into yellow, and then we start just going into green. We're around 530 odd, and look, there comes our electrons. Now basically if I go back, I can actually work out what the threshold frequency is for my sodium. So basically if I just tap it along a little bit more, we're actually going to be generating enough. There we go. We've just got some electrons which are being generated. They're coming out there. You'll notice that the current sitting down here is looking at 0. Now look what happens when I increase the wavelength. So this here would roughly be the threshold frequency of the threshold wavelength for our sodium metal. And the frequency is sitting just under, around about 0.5 times 10 to the 15 hertz. Now look what happens when I increase the wavelength of my light. So I increase my wavelength, you'll notice that the electrons begin to start getting faster. And as they start moving faster, they're getting more kinetic energy. And look what's happening down the bottom here. I'm actually generating a photocurrent. A photocurrent is being generated at 466 nanometers. If I increase it further, you can see that the photocurrent is getting bigger and bigger and bigger and bigger. Okay, and as a result, I can get a very, very big curve which is generated with respect to my kinetic energy as well as my frequency. But if I take my frequency back to round about that position there, we've gone back to a 0 photocurrent. Now we can do the same thing with different elements. So remember, round about 554, no, it's probably a wee bit more. Let's just whack that up and get another check. There we go, around about 535. 535 at 51% is what we were getting for sodium. So 535, remember that one. Let's go and check zinc. Okay, so we'll do zinc. We'll just let these finish off, and we'll move things. So it was 535 was the threshold frequency of sodium. So let's go to 535. There's 535, just about, and nothing's happening. So zinc will go a bit further. So now we're entering into the blue area. We've got a higher wavelength. Notice the intensity is the same, but now we've got to go right into the red, purple, and now we're entering the ultraviolet. There, 257 nanometers, and I'm getting my first. I'll just drop that down just a little bit. 200 and there we go, about 276, and I'm getting my first electron which is being emitted. So these are the threshold frequencies. Again, if I go higher on my UV, look at the shape of the graph that's generated, big current, and the result is I've got the same shape graph which has been generated on my on my graph, my same gradient. Now remember that gradient there will actually equate to Planck's constant, and as a result, as I go down, I can basically work out that the intensity is basically going to change the amount. So not the intensity, the wavelength is going to change the amount. So let's go back to, shall we do one more? Yeah, let's do copper. Let's see what happens with copper. So copper, you can see there copper on the left hand side in that ultraviolet area. Okay, so now we're at 202, probably a wee bit less. There we go, 240 ultraviolet for copper. So again, it's all different, and this is what this is trying to do, is to prove that the elements will only have a threshold frequency which is specific to them. It's not specific to anything else because of the makeup of the atom. Well, let's see what happens if I increase the intensity. So here I've got my zero current here. Let's close that one off, and let's look at current versus light intensity. What are we going to get? Well, if I increase the current, look what happens as I move up. Okay, you'll notice that I will increase with the intensity. I'm going to increase the amount of current which is generated, and the reason being is I've got more electrons which are being generated. Obviously, if I take this higher up, okay, I'm going to get a different amount, and you can see that by changing the intensity I'm getting more of a slope. If I go even higher, look what happens to my intensity which is generated. I'm still going to get different amounts of current linked to the intensity. So that basically explains how we can use the photoelectric cell to determine the threshold frequency. We can use graphs to use our threshold frequency. Remember, that will be where the graph, the curve, will actually cross the x-axis. We can read off our frequency, and from that we can then use Planck's formulae to actually determine the amount of energy that's been generated. Now, I hope you found that useful. So if we just go back, I'd just like to let you know that as well as the videos, I've also put up some questions that will allow you to work through, some worksheets that will allow you to work through some photoelectric questions and problems using graphs and theories and equations, and hopefully you'll find that useful. Also, do check out my Aussie Physics website, so that's aussiephysics.com, for other iTunes U courses, worksheets and other resources. They're all free of charge. Textbooks as well, which I've written, that you can utilize, and hopefully it will help you with your understanding of physics. So thanks for watching, and I look forward to you joining me again. Bye for now.